This is a box. Inside it, according to Schrödinger, is a cat that's both alive and dead. We run into this in software too, and it's maddening when it happens. No actual cats were harmed in the making of this video, unlike your production database, which has been both up and down all week, and nobody can prove which. You've probably heard of Schrödinger's cat. A cat is sealed in a box. Inside with it is a radioactive atom that has a 50-50 chance of decaying within the hour. If it decays, it triggers a mechanism that releases poison and the cat dies. If it doesn't decay, the cat's fine. Now, Erwin Schrödinger, the physicist this is named after, didn't design this to describe how the universe actually behaves. He designed it to sound absurd. Quantum mechanics was making strange claims about how the smallest particles behave, and he wanted to ask, if those claims are actually true, what happens when you scale it up to something as ordinary as a cat?
Oh, I know this one. The cat is both dead and alive at the same time.
That is the popular version. It's not quite right, and the real version is actually a lot more interesting. Before you open the box, the situation, whether the cat is alive or dead, hasn't been decided yet. It's not the cat is already dead and you don't know it. What actually exists is a weighted set of possibilities. Some chance the atom decayed, some chance it didn't. Not both are true, more like neither is true yet. Think of it like rolling 2 dice. You know the odds of every possible combination before they land. 7's the most likely, 2 and 12 are the longest shots. But you can't say what the actual result is until the dice stop moving. That's not because the answer was known but hidden the whole time. It's because there wasn't an answer yet. The result was still bouncing around inside those odds, shaped like a curve, some outcomes more likely than others. Now, what actually makes the dice stop? Friction, the table, something to hit. Throw them down a frictionless surface and they'd roll forever, never settling on anything. It's the interaction, hitting the table, hitting each other, that forces them to stop bouncing around the odds and land on one specific result. And that's the whole idea people call collapse of the wave equation. A name for the moment weighted possibilities, a curve of probabilities, turns into a single actual outcome. It's not a hidden answer getting revealed, a new specific fact getting made. Before that moment, there was no fact to find. The moment itself is what created one.
So opening the box splits the universe, one where the cat is dead and one where it's alive.
Ah, that is the many worlds interpretation. It's a legitimate interpretation, but it's not what this thought experiment is claiming. People mash the two together because multiverses are fun. This experiment is just about the weighted possibilities turning into one actual event. Not a mistake, not bad luck. Just what happens when the thing being decided isn't decided yet. You check something, one result. You check again, same input, same conditions as far as you can tell, different results. A bug that seems to change depending on when you're looking at it, or who is looking at it. But before we look into what to do about it, let's name the 2 different types of I don't know. Epistemic uncertainty means the answer is already known, you just haven't checked. Like the dice that settled to a stop under the couch. There's nothing mysterious, the result is there, you just need to find it and see what it is. That's regular debugging, even if frustrating. Indeterminacy means there's nothing to check yet because the answer hasn't been decided. Nothing is hiding, it just isn't settled. It's like the dice still rolling.
Well, that's kind of like a Schrödinger's deploy, isn't it? Did it work or did it break everything? Nobody knows until someone checks.
Yeah, that's not indeterminate. That's epistemic uncertainty wearing a costume. Go check the logs. Check the metrics. It already succeeded or it already failed. You're just choosing not to look. Now, the actual bug that changes between runs, that's the real thing. Think of a race condition. 2 processes, both reaching for the same resources. The outcome depends on which gets there first, and that hasn't happened yet. It isn't decided until it's decided, the same way the dice weren't decided until they settled on the table. Or distributed system state. You've got replicas that haven't finished syncing. Ask two different nodes what's the current value mid-propagation, and you could get two different answers. Neither one is wrong. The system hasn't turned its odds into one outcome yet. It's not lying to you, it just hasn't landed. And here's where the physics come back around. A race condition, a distributed system mid-sync, both depend on multiple interacting variables. Timing, ordering, which process, which node gets there first. Same shape as the dice, a spread of possible outcomes, and no fixed answer until something forces a landing. When a result changes between runs, same code, same inputs, different outcome, the instinct is to treat it as noise. Rerun it, blame the IC runner, try to figure out the exact steps that caused it so you can make it happen again on demand. Call it flaky test and move on. That instinct is the epistemic mistake dressed up as debugging. You're treating an indeterminate result as if one more look will finally reveal the real answer. It probably won't. There isn't a fixed answer sitting there to find. The variance itself is information. Here's a simple test to tell the two apart. Ask, is there a source of truth I can check right now? If yes, that's epistemic. Go look it up. Stop guessing. If the answer depends on timing or ordering that hasn't happened yet, that's indeterminate. And that's not a dead end. It just means the fix isn't look harder, it's design for it. Instrument the interacting variables themselves. Timing, ordering, load. Find out what's actually competing. Once you know what's racing, you've got real options. You just have to pick one instead of hoping the uncertainty goes away. Lock the resources so only one thing can act at a time. Make the operation safe to run twice so it doesn't matter who gets there first. Design the system to settle into a correct state eventually, instead of promising an instant answer it can't back up. None of these make the system deterministic. They make the indeterminacy safe, so it stops being your problem or your user's. Next time your Schrödinger's bug shows up, don't ask what's the real answer. Ask what's actually racing and decide how you want it to be allowed to end. Alright, time to open it. Two things to take with you. Not knowing something and it not being decided yet are two different problems. Treating them the same, assuming one more look will settle something that isn't settled yet, will burn you. And when a result depends on more than one moving part, a different answer each time you look isn't noise. It's the clue. Find out what's racing and design around it. That's how indeterminate systems get tamed, not by staring harder. Your production database, by the way, deployment's still both a success and a total catastrophe, until someone checks.